Hello everyone, today let's solve the problem number 139, word break. So what the question states here, we are given a string S, you can clearly see here, we are given a string S and a dictionary of words, word dictionary. You can clearly see here, word dict they have given, nothing but word dictionary. Here our task is to determine if S can be segmented into space separated sequence of one or more words from the dictionary. One or more words from the dictionary we can consider, and whether it can be segmented into a space separated sequence of one or more words, that we have to find out. The same word from the dictionary can be used multiple times, they have given. So the same word, this one from the dictionary, can be used multiple times. How many number of times you can use? There is no restriction at all. You can use n number of times they have given here. Same number of words can be used here, n number of times in the word dict. Whatever the words they have given in the word dict, you can use any number of words, any number of times you can use the same thing right here in the S. So that's what they have given. We output will be in the form of boolean right here. So here you can clearly see, let's come to example one. Here they have given Leetcode. Here we have Leet and Leetcode. By looking at it itself, we can say this forms a word from Leet and code here from the word dict mainly, right? So the output that we need to return here is true. By explanation, they have clearly given return true because Leetcode can be segmented as this one, Leet and code, right? So this one is fine. So second example they have given here as apple, pen and apple. So apple and pen they have given. They have said you can use this word any number of times, many number of times, as much as you can, right? So here apple, pen is present, apple is present again, apple is present twice. This doesn't so we can make use of apple any n number of times here, right? So at this one, for the output we have to return true here. I hope this is clear. Return true because apple, pen, apple can be segmented as apple, pen and apple. Note that you are allowed to reuse the dictionary word. They have clearly mentioned here in the explanation. Let's come to the example 3 here. Cats and dog they have given here. Word dict cats, dog, sand and cat they have given here. In this case false, right? So they have clearly we have clearly got here false. So this is one thing we have to keep in mind, right? So this is fine. I hope the question is clear here, right? So why here this one is false here, cats and dog? Because we have got cats, we have got dog, we have got and cat is not present and sand is not present here, and this one yes. So this one will be false here in this case. Sand and cat are not present, so this will be false in this case. I hope this is clear, right? So this is it for the question. I hope the question is completely clear. What we need to do is completely clear. So let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially what we will do, we will discuss the approach as usual, right? I'll just consider the same example, first example that they have given in the question. So let's discuss the approach first. So here we'll be making use of the first thing you have to keep in mind here is we will be making use of the dynamic programming here. To solve this particular problem, we'll be making use of the dynamic programming. So the same example that they have given in the question, I have considered the same first example, right? So let's start. So first thing is initialization. We'll be making use of the DP array, and this is the base case. So DP of 0 is always 1, right? DP of 0 is always 1. If they have not given anything, DP of 0 is always 1 because empty string can always be segmented. This one, empty string can always be segmented. This one will be considered as 1, right? This is one thing we have to keep in mind. Let's iterate over the strings. We have considered the same example, right? Leetcode, this one we are considering. So we are considering this one, this example, right? Let me come here. So first we have to iterate over the strings here. We will be starting at the index 0, nothing but DP of 0 initially 1, we know this one, and we have to try all the words from word dict. So here Leet, here this one is Leet, right? Here word dict Leet, this one Leet and code. So here what happens, Leet, this one leet matches s of 0 4 means 0 to 4. Leet matches 0 to 4 here. This one they are saying. So this leet matches 0 to 4 from word dictionary 0 1 2 3 or 1 2 3 4 we'll consider here 1 2 3 4. So 0 why 0 1 2 3 4 dp of 0 is 1. Initially we are considering empty string, so 0 to 4 I have considered here. This one 0 to 4 this matches, so dp of 4 will be 1. In this case it will be true. They are saying dp of 4 equals 1 is nothing but here leet matches 0 to 4 true. And next step is here we have to move to I equals 4. So here verdict, what is verdict here? Code, right? So we will move to 4, this one for I equals 4 right here 0 1 2 3. This is 0 1 2. This one is t is nothing but 3 here. We will move to step this one I equals 4 and we will start code 4 to 8 here 4 5 6 7 right. So this will be 4 to 8 we will consider, right? Here code matches s of 4 to 8, right? So code here we have code this one code this code actually I'm speaking of this code I equals 4 we have started from 4 5 6 7. This code matches from 4 to 8 from this one. Same thing, right? COD 5 6 7 and 8. So this one matches this one. Code equals code and here leet equals leet. So this will get matched correctly, right? This has matched correctly in this case. So this one dp of 8 will be 1 as well. Nothing but here when I say 1 this is true as well, right? So final step is here, since dp of s dot length is nothing but the length of the string here. So dp of length of the string equals dp of 8 itself, nothing but equals 1. It matches the word dict matches the string here. So answer is true. In this case we are displaying true. So this is the approach that we will be going with. So that's what we have discussed step by step. I hope this is completely clear, right? Let's discuss the edge cases one by one very quickly. So first thing here, just give me a second here. First step, I'll just come here. Let's consider the input. Same thing. So here we will be going with s equals. So this one is already given in the example. We don't have to, but still, apple pen apple. Let me give here word dict. Let me consider here word dict equals apple and pen. This is fine. So we can make use of apple n number of times. From this apple will be used twice and pen is used once. So this will be explanation apple pen apple. Segmentation is valid. So space will be there. One space apple. This is segmented as apple, then space pen, then space apple. So this can be segmented right here. You can clearly see. So the output will be true in this case. So let's consider the second edge case. So here input s equals cats and dogs. We have already seen this still. So let's discuss this one very quickly. Cats and dog. Word dictionary here. I'll just consider word dict here. This one will be cats, dog, and is fine. This one is sand. This is fine. This one is and this one is cat here. This is fine. I hope this is clear. That's what they have given in the question. So output will be false. Why output will be false here? Because no segmentation here exists at all, right? So no clear segmentation exists at all. We have to make use of sand and cat also here. No proper segmentation exists at all here. So output will be false in this case, right? I hope this is completely clear. So these are the two edge cases that we need to consider. I hope this is clear. Next, what we will do, let's start writing the code. So let's start writing the code here. As we have discussed already, let's create a DP array of size length plus 1, length of the string plus 1. length plus 1 by, because just for the easy computation we'll be considering extra this one, extra one space. So initialized with, initially let's initialize that one with 0, right? So I can just write it in this way. Let dp equals new unsigned 8-bit array I'll consider, right? This is fine. U and 8 array of length of the string plus 1 in this case. So next step here is base case. We have already discussed that an empty string is always breakable, right? So we have already written this one. We know this from the approach. dp of 0 is 1, right? So this is fine. Next step is we will convert the word dictionary into set for the quick lookup, right? So that it doesn't get repeated. That's what it helps in set. So I'll just give here set equals new set word dict, so that the word doesn't get repeated here. That is the reason I'll will be making use of set here. I hope this is clear. So the next step is we have to iterate over the string characters, right? So for that I'll just make use of the for loop. So let I equals 0, I less than length of the string, I less plus. This is fine. Next step, within the for loop, what we will do, if the current index I is reachable, nothing but iterated value of the dp is true. So the nothing but if current index I is reachable. So I can just write here if dp of I. That's it. Simple if condition. So within this if condition, we have to check all the words in the dictionary, word dict, right? So we have to check all the words in the word dict. Word dict, we have considered that one as set. We have converted the word dict as the set of words, right? So here I have considered the variable set instead of the word dict. So we will be considering set, individual words of set, right? So this is fine. So this has to be for loop. Just give me a second here. I missed this one. So this is fine. Yeah, this is fine. Within the for loop, if s of I starts with the word, nothing but s of I is here, iterated value of the s, it starts with the word w. Word w means this one. Leet starts with the s of this one, starts with the word w, this one and this one in this case. First example we have considered, right? If iterated value of the s starts with the word w, then what we will do, we will mark dp of I plus length of w as reachable. This is reachable. We made this one as 1, right? Next, this one we check for code and code. This also match this one. dp of something, we set this one as 1. dp of 4 and dp of 8. We had set this one to 1 if you remember. Finally, we got true from the same thing, right? From the length. So what I'll do for this, simple if condition here, if s dot starts with here w comma I here, this is fine. What we'll do, we'll mark dp of I plus length of the w as reachable. This will be dp of I plus w dot length. This is fine. This one we will set this one to 1. I hope this is clear. Let me let me format the code once, and the final step we have to return whether the full string is breakable or not, right? So I'll just make use of double not in this case. So I'll just go with double not of dp of length, right? So we are checking whether the full string is breakable or not, or full string is can be segmented or not. That's what we have to check here, right? Word break. So here we just have to return whether the string whether the full string is breakable in this case. So let me format the code once and let me hit the run button. This is it for the code. We had discussed this one in the approach step by step, right? If you remember. So yeah, you can clearly see here the sample test cases are getting passed. I'll quickly hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case. Let's quickly discuss the complexities of the code that we have written, right? So the approach that we went with here is dynamic programming. We know that, right? So what would be the time complexity here? The time complexity, overall time complexity would be big of m into n, or we can consider here n into m as well. Doesn't matter, but n into m we have considered here means n is length here, this one. Length of the s, this comes first, so it is better to consider n into m itself here. You can go with m into n, both are same. N equals s dot length, and m is nothing but here this one, average length of the words in word dict. So this one, average length of the word in word dict. So n is length of the s, nothing but length of the string. M is average length of the words in word dictionary. So what will be the space complexity here? Overall space complexity would be here big O of n, right? So overall space complexity is big O of n. Why it is big O of n here? We are making use of the DP array. You can clearly see unsigned 8-bit integer array we are making use of, right? So this is of n. This requires space n. So overall space complexity would be big O of n as well. So the time complexity would be big O of n into m, and the space complexity would be big O of n in this case. So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.